Good morning and welcome to our second lesson introducing the imaginary number I. And this lesson is going to cover, it's kind of like an interesting little side topic, like higher powers of I. Now, to be completely honest with this, this is a totally useless skill. And this is just completely random, but it is assessed. It is the kind of thing that you are likely to see on tests. And it does open up the idea or the realm to some kind of interesting ideas in different branches of math that I kind of like to get into and cover with you guys. So we are going to cover higher powers of I. Follow along with the reasoning as always, and guess I'll see you at the end. So we're going to start off with this introductory question. I am going to pause the video in our virtual class, and we'll stop the lesson obviously in the face-to-face class because I do want you to kind of think through the answer to this question, and not just what the answer is, but how you went about finding the answer. So here's the question. At the time of this recording, I have no idea what day of the week I'm going to be doing this lesson, so I left this blank. But if today is, whatever today is, so if we're doing this lesson on a Tuesday, if today's Tuesday, whatever day of the week today is, what day of the week will it be 243 days from now? So, for example, again, I don't know what day of the week it'll be when I do this, but if today is Tuesday, what day of the week will it be 243 days from now? If today is Wednesday, what day of the week will it be? So I'm going to pause the video and I'm going to give you a few minutes to think about this. When you think you know the answer, go ahead, type it in the live chat, and then I might call on you to explain how you did it, or you can type how you did it, how you went about getting it, because that's what I really want to drive at in this. So there are a variety of ways that you can come up with the answer to that. One of the ways is to just like take a calendar and count out 243 days from today to figure out what day of the week it is. But I am willing to bet that that is not how most people went and found what day of the week would it be 243 days from now. Because as soon as you start thinking about it, you come across this key idea, which is this: the days of the week repeat after you get to 7. And so you have like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then the 8th day, Sunday, is actually the same as the first day. And then you might go do Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and so forth. And the 15th day is the same as the 8th day. Like those are all Sundays. And so you exploit this in order to create a shortcut so that you don't have to count all the days out like 243 times. So one of the ways that people do it, and they'll describe it different ways, and I don't know what kind of discussion we had in class on this or how that went, but usually what people will do is they'll figure out like how many chunks of 7 do we have, and then what you really care about is how many days over that do we go, because that tells you where in that final week you are, and you don't really care about all the times that you loop through the 7 days. Now, this has a name, and it's something you can actually study at a higher level. Okay, so I do want you guys to know that math is bigger than what you just study in high school. So there's a lot of really cool and really interesting things out there. This kind of arithmetic, okay, what you're doing when you do this problem, this is arithmetic mod 7. Okay, and what it's known as is called modular arithmetic. So you have known arithmetic for a long time, that there is something called modular arithmetic, where say the number 1 would be the same as the number 8 mod 7. And that's like saying like the 8th day of the week is the same as the first day of the week if you're counting in chunks of 7. So Sunday is the same as Sunday. because you're counting in a chunk of 7. There's a ton of stuff you can do with that, and you can do arithmetic mod anything. So you can do mod 7 for the days of the week. You could do mod 24 for hours in a day. You could do mod 12 for months of the year. So anything that repeats in these chunks, there's a whole branch of mathematics, and there's a ton of stuff that you can do with it in a branch of math called number theory. So kind of file that away as something fun and interesting that you did not know before today. So if somebody asks you, what did you learn in math class today? You can say, I learned what arithmetic mod 7 was. So why am I starting off with that? It's because our powers of I are going to have a modular property to them. So we're going to start looking for a pattern. All right, so we know that there are patterns in math. I'm going to start with I to the 0 power, I to the 1st power, I squared, I to the 3rd. Looking at my notes. In my notes, I went all the way up to I to the 6th. So we'll do I to the 5th, I to the 6th. We'll go up to I to the 7th on this one. So we're taking our imaginary number I, and we are going to basically do it out in powers. Now, this we haven't really gone over yet. Hopefully you have seen it somewhere before, where you have something to the 0 power. I will go through the laws of exponents, but pretty much anything to the 0 power except for 0 is equal to 1. It's a little bit counterintuitive. You're probably wondering, I'm not sure I buy that. But if you have a calculator handy and you're skeptical and you think that your math teacher is leading you astray, okay? So we're going to do some scratch work. Go ahead in your calculator and do 5 to the 0 power, and I promise you your calculator will tell you that it's 1. And we will go over that in a future class period when we go over the laws of exponents. But and I can show and explain to you why that's equal to a 1. But for now, just like anything to the 0 power except for 0 is 1. So I to the 0 is equal to 1. I to the 1st power, where anything to the 1st power is itself. So, I mean, that should be pretty self-evident. 5 to the 1st power is 5, and 6 to the 1st power is 6, and 7 to the 1st power is 7. So I to the 1st power is I. So what we're building over here on the left, we have I to the 0 is 1, I to the 1st is I. I squared goes back to what we studied last lesson. It's part of the definition of I. I squared is equal to -1. So notice we have 1I, -1. Now we really need to start doing some scratch work over here, because now we're getting into things that we haven't seen before. So I to the 3rd power literally means I times I times I. So that would be I squared times I. So what I did was I just grouped these two i's together to get I squared times I. But we know that I squared is equal to -1. So -1 times I would just be -I. So far, so good. Now let's take a look at I to the 4th. I to the 4th is I times I times I times I. Well, I can break these into 2 groups of I squared. That would be I squared times I squared. But we know that I squared is equal to -1. So this is -1 times -1, and a negative times a negative is a positive. Now notice what just happened there. I went 1I, -1, -I, and I to the 4th looped us back up to I to the 0. And so I'm repeating the 1. So it looks like the pattern has started over again. We can't know that for sure until we look at more. So let's look at I to the 5th. Well, I to the 5th would be I to the 4th times an extra I. Makes sense. Like, I'll give you a moment to kind of think that through. 4th. But I to the 4th is 1. So what this really is 1 times I, which is I. And now it really looks like we're starting this pattern over again. 1I, -1, -I. 1I. If this is -1, then we'll know that our pattern is continuing. So we have I to the 6th. Well, I to the 6th would be I to the 5th times an extra I. But I to the fifth was the same as I. So this would be I times I, which is I squared, and I squared is equal to -1. And I have one more on there. I'm actually out of colors, so I guess I'll open up a new color. I to the seventh would be I to the sixth times an extra I, but I to the sixth is -1. And -1 times I is -I. Now, notice the pattern over here. And we have no reason to think it would not continue. If you really think that I am duping you one, you could do I to the 8th and I to the 9th and I to the 10th, but probably you don't want to do that because it would take a long time. But we have a pattern established. We have 1I, -1, -I, 1I, -1, -I. If I were to do I to the 8th, we'd start over with the 1. So what I want you to notice here is this block. This is like the days of the week where you have like Sunday, Monday, Tuesday, all the way through Saturday, and then you reboot over with your Sunday. But you could find basically any day of the week is going to fit in that block. We have it here, instead of a pattern of 7, we have a pattern of 4. So 1I, -1, -I, 1I, -1, -I. What that means we can do is that we can exploit that pattern to find higher powers of I. Just like in the introductory problem, you could exploit the pattern of the 7 days in a week to bypass this like huge number there and figure out what day of the week it would be 243 days from today. So in this, we actually have a pattern of 4. So we have I to the 0 is equal to 1, I to the first is equal to I squared is equal to -1, and I to the third is equal to -I, and then they would repeat. So what we're going to do, and this gets into why I wanted you to not just find what day of the week it would be, but pay attention to how you found what day of the week it would be. And anybody who takes the shortcut does some variation of division. Sometimes students won't describe it with division, they'll actually describe it with factoring. So they'll say something like, well, I rounded the 243, or I did 7 times something, gave me a number close to 243, which would be doing it with like a factoring instead of a division. We're going to do this with division. So let's take a look at this example problem. If you have I to the 243rd power. Okay, so we'll stick with the number 243. What we want to figure out is where, when we cycle all the way through this, where is the 243 going to land? Just like you did with the days of the week. Like you weren't really interested in how many times you have to go through the days of the week. You want to know where on that last week is it going to land. So the way we do this is we're going to take that exponent, and instead of dividing by 7, we are going to divide by 4. In other words, we want to figure out how many cycles through that will this go. And then we're going to look at the remainder. And the remainder is going to tell us where on this list it falls. So going through our long division, 4 goes into 2, it doesn't. So you go 4 goes into 24, 6 times. 6 times 4 is 24. Which is a 0, bring down the 3. 4 doesn't go into 3 at all. Multiply, and you have a remainder of 3. Now what that means is that I to the 243rd is equal to I to the third. So your remainder tells you where on this list it actually falls. And so if it's I to the third, then that would be equal to -I. So the only ones you really need to memorize are the first 4. I to the 243 is equal to -I. I have another one here. I have I to the, what in heaven's name is that? I to the 29th. And so we're going to find out where, now you could count like I to the 29th. So you do 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, you could do it that way. Or you could do 29, divided by 4, goes in 7 times, with a remainder of 1. And so that would be the same as I to the first power. Notice what this number is it tells you how many times it's going through, but you're not really interested in that. Like, we don't really care how many times it goes through. We care about the remainder. We're caring about the thing that's left over. So that makes using a calculator a little bit awkward with this, because you're not interested in the number, you're interested in the remainder. Now, there is a way for you to figure out the remainder from doing it on your calculator. So, if we have time, that's like a question you can ask. You can hop into tutoring and ask me. I to the first power is just I. And of course, this would work with much bigger numbers. So if you had I to the 3,420, I don't know, 22nd, okay? You would take 3,422 divided by 4. So this goes in 8 times. Subtract 5 times, subtract another 5 times, and we have a remainder. I don't know what I tapped on, but we have a remainder of 2. So this is equal to I squared, which is -1. So I got a couple practice problems for you to do. Again, what I mentioned is this is like a totally useless skill. I can't think of any realistic situation where you would need to figure out higher powers of I, but again, the concept is an interesting concept. The idea of cycling through on a pattern and figuring out where you would land on the pattern, and it introduces this idea of modular arithmetic, which I think is just interesting regardless, and it's a good way of training your brain to think in patterns and to exploit patterns to figure out what you want. So here are 3 practice problems: I to the 302, I to the 44, and I to the 39th. And there is one thing I want to do about graphing calculators last, so yeah, so we'll pause the video and let you work on these. And here are the answers. For the first one, you should have gotten a remainder of 2, which would be I squared. So I squared is equal to -1. For the second one, you should have a remainder of 0. And so I to the 0 is equal to 1. So your answer would be 1. And for the third one, you should have a remainder of 3. So you'd have I to the third, which is -I. Notice that in the practice and in the examples, we have covered all of the possible different situations for a remainder so that you can see what they all look like. Last little thing that I wanted to cover in this lesson is graphing calculators. And so graphing calculators and some scientific calculators actually have what's called a complex mode. And so if you put it in complex mode, how you do that would be different. But it will actually work with imaginary numbers. So what we'll do in class is if somebody imaginary numbers. What we'll do in class is we'll demonstrate, and we'll go back to the original problem that we were doing a class period or so ago with the square root of -4, and your calculator will give you the I out. So it is a nice feature of your graphing calculators. I'll probably make a video on that shortly. And that's a wrap on our introduction to imaginary numbers and higher powers of I.